Okay guys, in this video I want to show you a way to add dynamic wave crests to a geometry that you get from the Houdini Ocean Toolkit for Max plugin, which is quite nice. So we are going to check out the way to basically do stuff with Stoke, and in it you might find bits and pieces that you can maybe that you might like and you might find useful in your own stuff, be it wave crests or anything else. So you can see here that's what like a very rough render it would look like, and this is what the original geometry looked like. So the way I plan of doing this is that I will get the velocities of that vertices and specifically their z component. So when the velocity of the vertex goes down, this is when that's how I'm gonna find where the wave crests are. I'm gonna put particles on them, and I'm gonna emit from these particles in a Stoke sim, which I will use to add some nice motion to it. So first, the Houdini Ocean Toolkit for Max, very nice plugin written by Guilherme here, and you might Google it and you might check it out. It's really cool. I have this thing here point cached just to have like a solid start point to do stuff on, and I will emit first my particles like the seed ones that I would emit stock out of. So I'll use the purity surface. And place it in the origin and use world space here. So if I add the surface as a source, you can see that playing back the animation, the particles do move with the surface, which is nice. But when I look in the data viewer, you can see that there is no velocity channel here. So I need first to produce this somehow. Now, Bob will tip me off that if you cache the surface with Xmesh instead of just point caching it, Xmesh can get this velocity channel for you, which is very cool. But before he gave me this idea, I did it in another way, which I'm going to show you now. So what I'm going to do is that I will actually copy the geometry object, and because it's point cached, I can just offset it with one frame and color it differently so it's visible. So basically, making this copy, which is one frame offset, is going to allow me to get these particles that I had there before and look at the closest point of that other object, the gray one, which is one frame later, which starts one frame later, meaning the animation is one frame earlier, and the difference between, like the distance between the particle position and the closest point on the other object's position is going to give me the velocity, because this is basically the position where the thing was at the previous frame. So I will get like what is pretty much the velocity. So I'm going to make this with a magma modifier. So put one magma modifier. I will get shift P the position. I will get input geometry the object. That's the copy I made, and I will do object nearest point. These inputs are reversed, so I'm gonna hit Ctrl W to put them back in order, and then I will subtract the position of the nearest point and from the position of the particle. Now it says world space here, lookup point world space, but as you know, I have checked the world space here, so that's fine. So this vector I can send to viewport color, normalizing it first, just selecting the both hitting space. Now if I hit auto, you can see that I have the green areas. It's where the crest is going up. Like if you look at this crest here, for example, so the green areas is where the crest is going up, and the blue areas is where the wave is going down. So I will need basically this like blue sides. So I will also send this to the velocity, obviously. without the normalize, just so I also have the magnitude. Okay, and then I can rename get velocity, and in another magma modifier I will actually filter only the wave crests, so I can emit from them. And the way I'm going to do it is that I'm going to get this blue and I'm going to remap it to another color. So basically to filter, to make everything black besides the stuff that I need, and I will use this as a selection channel and just delete all the other particles. So I will get the velocity, Shift V, and I will normalize it because I only need the direction, so because I only need to know when the thing is going down. And I will use a curve to just, remap it. Then to be able to see what I'm doing, I will use a function F and then blend, and Shift 0, Shift 7 is blend between black and white, and selecting them with the space bar and connecting them. This is awesome, the way the magma modifier works. Bobo, awesome stuff. So this way I'm going to be able to see at what's going on, and I will use the viewport color again to just be able to look at this stuff in the viewport. This guy says the curve is not liking the input type, and that's because I'm giving it the whole vector and I need to give it only the Z. So I'm going to get the breakout and I'm going to connect the Z. So you can see here I have white areas where the descending stuff is, but I need to I want to make it a bit better, in the sense that I want to only emit where the initial stuff of the descent is. Like, I don't want to emit where the lowest portion of the wave is, which means only when the velocity starts going down, that's where I want to emit. I can do this with the curve, fortunately. So this guy can go also 0. Make all of them corner for now, and just I'm gonna dial the curve that I think is working, as far as I remember. So something like this. You see I have a kind of softness. So I will be emitting less where the lower side of this is, and I will be emitting softly as the whole thing appears. If you look at it from a bit far, you can see that the wave pattern is already quite visible. And of course, with this, just with the keys of this curve, you can adjust the thing quite a lot. So you can make it, to your liking. Smooth should be fine for now. So to be able to emit only from these white areas, what I'm going to do is that I'm going to delete the rest of the particles, and I will use the selection channel for that. So selection channel, and I will get that curve, but the Krakatoa delete modifier is only deleting the stuff which is white. Basically, you can use it this color as a soft selection, but it will delete the white stuff, and I want to actually do the other way around. I want to delete the black stuff. So I will get that curve, and I will invert it by doing 1 minus. So basically, I'm gonna send 1 minus the curve in the selection channel. And then if I put the Krakatoa delete modifier and I say soft selection plus a plus ID, you're gonna see that I have a nice soft delete. So basically, the whiter the particle is, the less chance it gets of being deleted. So you're going to have a lot of white particles and not many dark particles. Okay, so this is pretty much ready to emit Stoke out of, and I can make a new layer for the Stoke. Yeah, Stoke object. So what Stoke needs is two things basically. It needs distribution source, which is where it's going to emit particles from, and it needs a velocity field source, which is where it's going to pick up the velocity out of. Now, this thing is going to work fine for emitting particles out of, but the problem with this would be, like, if I use this for a velocity field, obviously here there is no velocity. Like, it's not gonna want it is not gonna know what to do with this stuff here. So I'm gonna make a copy of this, and I'm gonna remove the delete modifier, so it can actually move the particles even at the black areas. And I will use this one for velocity. Now the scale here, which is 1, is quite small, just because the offset that I had there between the two sorry, between the two geometry objects was so small. So just increase this to 100. And there is the nice thing here, create fluid motion. Now the purity surface, I can maybe decrease the particle number a bit, just, you know, for tutorials purposes, so we don't end up waiting too long. And also on this one. And then in the Stoke, I wanna define particle age, because I don't want this to I don't want to emit like just once. I want to keep emitting off the wave caps, and I want to have this trailing, like as the wave cap is going, it should be trailing this effect. So last thing I can do is that I can choose a channel that the Stoke might acquire from the original particles, and I can, for example, say put in one more magma modifier. Actually, I'm gonna go here because I'm only having the thing as a viewport color now, which is not something that I would, you know, transfer around. I will actually duplicate it as the color. Okay, so then Stoke. Though Stoke can pick up the viewport color, but having it as the color just like feels more natural, like less confusing. Okay, so I will check this color, and this means that the particles the Stoke emits are gonna get the color channel from the distribution source particles. Now, the last thing I have is just like here the simulate ranges and rate. So let's say this camera rate will be more interesting, and then I can hide the original stuff and hit simulate. Stoke is not going to give me an update unless I check out this here. And you see, if I move the thing around, I will start getting some stuff. Simulates quite fast. Like millions of particles are just a routine for Stoke. In this case, we're not going to have that many. I think it's like a few dozen thousands, which is fine. And you can see already from the motion in the preview that we have some nice fluid motion. You can see here this curling, which is quite cool. Now, of course, all this stuff is definable by how much velocity I give it here. And the cool thing is I can add other velocity sources. Just add a turbulence, or just add some field which is going outside of an object, so the whole thing kind of collides. You can do a lot of cool stuff, especially, you know, going into the field portion of Stoke. Very interesting. Probably here this 100 is a bit too much. You can see how all of them are forming this cresty shape. But of course, you can do a mixture of stokes, so you can just go and you can cut out the parts of the distribution sources with a texture, and you can have one stoke, and then you can cut out with another texture, have another stoke, so you have these different characters of stuff there. So let's make it a bit smaller just to have it more visible, just to have it more like underlining the structure. And what I can do, what I think I did in the original thing, was that I color them by the age. And while stock is actually simulating, I can do that, which is very nice. So I will get the age, Shift A, and lifespan, Shift L, and I will divide them just with the divide key on the numpad. So this will give me a 0 to 1, and I will map it with a curve, which is F curve. And I will send this again to the viewport color just to be able to see what I'm doing. Again, not forgetting that I can actually use the original color that I picked up, but I shouldn't be sending the curve to the viewport color. I should be sending a blend, which has, again, white to black. So if I do that, I obviously need to reverse this to be white to black, not black to white. So you can see that I get this wave character. And I can do some more interesting stuff with the curve. Let's say I want to have it in the beginning, like grow slowly. Actually should be going fast towards the, if I want to have the wave more defined, should go faster towards the black. You can also do something like, if it goes a bit first, like first if it is first in the black and then it grows, which is gonna protect you from that popping character. So basically, in the beginning, when the particles have not yet taken any fluid motion, they will be not visible. If you use, for example, this thing as density, and they will become visible just a few frames later when they have already the fluid motion going. We can do stuff like this, curve stuff, standard. So let's go back to the first one. Just for it to be simple. And you can see like they appear, then they move, and then they fade off. When you do this stuff with enough particles, it's gonna be great. So you see here that there is the motion. If I unhide the modifier, you'll see, I'll make them a bit brighter. Give them maybe some more oceany color. So you can see that they are moving nicely with the surface. And of course, the whole thing is volumetric. Stoke simulation and like advection is doing the stuff in 3 dimensions. So you're gonna have some depth to the whole thing. And basically that's it. Nice emission pattern. Out of flexibility, out of here, you can augment it with textures mostly, like most easily and the greatest result. So basically, you can just take a texture and cut out, let's say, foam patterns with a texture like this, for example. So you would delete all the stuff which is not in a cell. And because it's so fast, you can easily make a lot of different elements and just combine them. Different emission patterns, different velocities, all this kind of stuff. So usually I would just combine, like 3 or 4 of these things eventually, and you'll get a nice diverse effect. So that's pretty much it. I hope you guys liked it, and see you next time.